Hello, and welcome to our first lesson on factoring. In this case, we are looking at factoring any expression that is in the form of x squared plus bx plus c. So what it means with the x squared first is that our leading coefficient in front of the x is always the number 1. So all of these expressions, or trinomials in this case, will start out with just an x squared. So there's two setups to keep in mind before we worry about anything else. If c here is positive, so if the c at the end is a positive value, we know our final setup is going to be an x minus a number and an x minus a number, or an x plus a number and an x plus a number, which we'll explore in these first three examples. So looking at our factoring, and at this point, I'm going to stop just for a second and say, hopefully you watched the 3 factoring videos that were already posted to cover some of the basics and different approaches to factoring. If you have not yet watched those videos, you are going to want to make sure you go back, watch those 3 videos, and then pick up at this point, because some of the stuff that I will kind of skim over or not go in as much depth is covered in those 3 videos. So if we look at A, we have x squared plus 7x plus 10. So when we are factoring, what we always want to keep in mind is we are going to factor it to 2 numbers here that multiply to give us the final number, and when added, give us the value in the middle. So when we're factoring, we look at the last number first, and we want to think about numbers that would multiply to be that value. And then we look at the middle number, and we want to think out of those products of 10, or factors of 10, out of those factors of 10, then which of those factors add to be 7? So in this case, if I'm thinking about factors of 10, I have 1 times 10, or I have 2 times 5. Beautiful writing from my nice little scrolling cursor here. So if I have 1 and 10, well, 1 plus 10 is 11, so I know it can't be that combo. 2 plus 5 is 7, so this is the group that I'm going to use. So then when we use that, we will then look at our setup, and in this case, if the middle value is a positive, the last value is positive, I know I'm going to use this setup here, because when I FOIL this, I need it to add to a positive 7. If the middle value was a negative, then I'd be using this top setup because of negatives. So in this case, we could set this up either way, but I wrote it as x plus 5 times x plus 2. You could also write it as x plus 2 times x plus 5. Now, the way that we check this is by FOILing. So if I were to take my 2 binomials here to check my work, I'd want to FOIL them. So x times x is x squared. In the middle, 5x. On the outside, 2x. And the last is 10. So that would add up to be x squared plus 7x plus 10. Now in B. In B, I notice my final value is 12. So I want to think about numbers that multiply to be 12 and that would add up to be a negative 8. So in this case, factors of a positive 12 would be, we'd have 1 and 12, we'd have 2 and 6, or we would have 3 and 4. Well, in this case, we want to think about which ones of these three options could be put together to give us the value of 8. Well, 2 and 6 gives us 8. 1 and 12's not 8. 3 and 4 is not 8. So we'll be using the 2 and 6. Now, what you want to keep in mind with the 2 and 6 is that because this value in the middle is a negative 8, our setup would be x minus 6 times x minus 2. That way, when we FOIL it, with foiling, first we would have our x squared. So x squared. Outer, we would have minus 2x. Inner, we'd have minus 6x. And last, we'd have plus 12. So then in the middle, if we combine like terms, negative 2x and negative 6x gives us our negative 8x. And then in C, x squared minus 16x plus 39. So again, because it's a positive at the end here, I'm looking for factors that multiply to be 39 and add to be 16. But because the middle number is a negative, I'm going to use my top setup here of x minus and x minus. So then, what numbers multiply to be 39 and add to be 16? That would be 13 and 3. So our final answer is x minus 13 and x minus 3. So then D, E, and F. In D, x squared plus 17x plus 60. So again, we're thinking about products of 60. So we have 1 and 60, 2 and 30, 5 and 12, 3 and 20, 4 and 15. Well, which of those options add to be 17? 5 and 12 add to be 17. So our factored version would be x plus 5 times x plus 12. And again, you can reverse that order and write it as x plus 12 times x plus 5 if you prefer. In E, I'm looking for something that multiplies to be 24 and adds to be a negative 11. So I know I want a negative and a negative, or minus minus. So in this case, 8 times 3 is 24. 8 plus 3 is 11. Both are subtraction to give me the subtraction in the middle. And then in F, if I'm looking at F, I know in this case, I want something that multiplies to be 18 and adds to be 10. So in this case, multiply to be 18 adds to be 10. Products of 18 would be 2 times 9. That adds to be 11. 3 times 6 adds to be 9. 18 times 1 adds to be 19. Now, for our level, we don't need to worry about this discriminant part. That was for the regular school year, so don't worry about that piece there. But if you come across products here that do not add to be the number in the middle, then your answer is can't be factored. So in this case, because our products of 18 do not add to be 10, we cannot factor that expression. Now in example 2, we're going to look at what happens if our final value is a negative. So if c at the end is a negative, so x squared, then it's minus 12x minus 64. So if at the end it's subtraction or negative, our setup is always going to be an x plus something and an x minus something. So in this case, x plus, x minus for these examples that end with c being a negative. Then we want to think in this case, because c is a negative, we then look at the number in the middle. My number in the middle is a negative 12x. So what that tells me is I need more negatives than positives in the end. So my larger value will go with the minus or the negative. That will create the negative in the middle. Then, instead of thinking of two factors that add to be the number in the middle, because in this case we have the plus minus, we want to think about two factors that subtract, or the difference is 12. So 16 times 4 is 64. 16 minus 4 is 12. Then when we're setting it up, because it's a minus 12x, I need it to be x minus 16 and x plus 4, which gives me more negatives than minus 12x when we FOIL. So in B, I notice right away in the middle, after c is a negative, I have a plus 10x. So I need more positives than negatives. So I want to think about two numbers that multiply to be 75, and that when I subtract them, their difference is 10. So 15 times 5 is 75. 15 minus 5 is 10. And it's x plus 15 because more positives than negatives, and then the x minus 5. And again, if you would FOIL this to double check, you would get this expression here. In C, x squared plus 4x minus 42. So in this case, c is a negative. We have a positive 1x in the middle, so more positives. 7 times 6 is 42. 7 minus 6 is 1. So x plus 7, x minus 6. And then in the next part, D, we have x squared plus 9x minus 1. So something that multiplies to be 1 and subtract, or difference, becomes 9. The only thing that multiplies to be 1 in this case is 1 times 1. There is no way we get a 9 out of that in the middle, so that cannot be factored. And again, don't worry about this part down here. That was for the regular school year, so this piece here, don't worry about. In E, x squared minus 3x minus 10. So again, c is negative, so I have a plus minus. 2 and 5 multiply to be 10. 5 minus 2 gives me 3. And I need more negatives, so it's x minus 5. And then in F, x squared plus 14x minus 15. So something that multiplies to be 15, and the difference is 14. So 15 times 1. We need a positive 14x in the middle, so it becomes x plus 15, x minus 1. So those were all examples of how we factor and use it to simplify expressions. We can also use this process to solve equations. So we have 4 steps for solving equations by factoring. first we have to write the equation in standard form so that it's set equal to 0. Then we factor the left side. We set each factor equal to 0, like you did in the last practice assignment, and then we solve each of those equations. So if we look at A here, in A, we have x squared minus 6x equals 72. So first I need to write that in standard form and have it equal 0. So I need to get my 72 over to the left. So I subtract 72 from each side, and I end up with x squared minus 6x minus 72 equals 0. So then I need to factor this expression of x squared minus 6x minus 72. That factors to x plus 6, x minus 12. Because we need two numbers that multiply to be 72, and the difference is 6. Then to solve, you take each of these binomials and set them equal to 0. So x plus 6 equals 0, x minus 12 equals 0. And then you solve each for x. So on the left, we would subtract 6. So x would be a negative 6. On the right, add 12. So x would be 12. So the answer to this question would be a negative 6 and a positive 12 could both work. In B, we have x squared plus 17x plus 42 equals 0. Already in standard form, so we just need to factor the left. So we're looking for two numbers that multiply to be 42 and add to 17. So we have x plus 3, x plus 14. Split those each and set them equal to 0. So x plus 3 equals 0, x plus 14 equals 0, and solve each for x. So x could be a negative 3, and x could be a negative 14. In C, we have to write this in standard form. So we need to get the positive 20 over to the left. So we'll subtract 20 from each side. And we have x squared minus 17x minus 38 equals 0. So then x plus 2 and x minus 19 when it's factored, because two numbers that multiply to be 38, and the difference is a negative 17. Then we split this and set each of these equal to 0. So x plus 2 equals 0, x minus 19 equals 0, and solve each for x. So x equals a negative 2, and x equals a positive 19. So if you do need more practice with these solvings, there's 3 more examples here with the work shown for you to work through. The word problem at the bottom here is a challenge problem that was kind of just be a go above and beyond concept if you want to take a look at it. For summer school, this one is not a required piece. It's, again, an extension idea. So if you want to look through it, feel free. But the main focus is going to be on these types here, the 4 steps on how to solve, and these 2 different setups up here, the setup for when C is positive and for when C is negative. Again, I highly encourage you to make sure that you watched and went through those 3 other videos on factoring, because they go through it with slightly different explanations, show some different approaches, and I'll be quite honest, there's quite a few ways you can explain factoring as a teacher and learn it as a student. So I'm trying to give you multiple ways to help you best understand.